Good day. Welcome to today's class on Riemann integral. In today's class, we'll be evaluating Riemann integral using limit definition or Riemann sums. Remember in the last video, we said that our Riemann integral, that is the integral of the function f of x from a to b, is what? The limit as n tends to infinity of the summation of f of x sub I delta x as I moves from 1 to n. We'll be using this to solve an example today on Riemann integral. The example says, evaluate the integral of this function x squared minus 2x plus 4 dx from minus 2 to plus 4 using Riemann sums. We want to evaluate this using Riemann sum. From this, what are the information that we have in the question? What are the information that we have in the question? Our f of x is what? X squared minus 2x plus 4. Our interval AB is what? Interval minus 2 to 4. That tells us that our A is minus 2 and our B is 4. Immediately from there, we can get our delta x. Recall from previous videos that our delta x is what? B minus A over n, and that is 4 minus 2 over n, that is 6 over n. If delta x is 6 over n, you will also recall from previous video that our x sub I will be what? A plus delta x sub I. And this is what? Minus 2 plus 6i over n. That is our x sub I. If that is our x sub I, then our f of x sub I now will be what? Our f of x sub I now, which is x sub I squared minus 2 into x sub I plus 4. This gives us what? Minus 2 plus 6i over n squared minus 2 into minus 2 plus 6i over n plus 4. I need to do something to that. Expanding that, minus 2 plus 6i over n into minus 2 plus 6i over n, that gives me 4 minus 12i over n minus 12i over n plus 36i squared over n. This gives me what? 36i squared over n. If I rearrange, minus 24i over n plus 4. Our summation f of x sub I gives us 36i squared over n minus 24i over n plus 4. Then we open this other bracket, plus 4 minus 12i over n plus 4. Now we bring it into the limit definition. The integral from minus 2 to 4 of x squared minus 2x plus 4 dx is what? From here, because we said that it is the limit as n tends to infinity of the summation from I equals 1 to n of f of x sub I delta x. This is the limit as n tends to infinity of the summation from I equals 1 to n of all of this. And that is what? 36i squared over n. This minus this also give us minus 36i over n. 4 plus 4 plus 4 plus 12 into our delta x. Remember our delta x is what? 6 over n. This should have been n squared. N squared. N squared. And so by the time we open it with that, we have the limit as n tends to infinity of the summation from I equals 1 to n into 216 I squared over n cubed minus 216 I over n plus 72 over n. We still have our limits, don't forget. Limit as n tends to infinity. And we try to take the individual summation of all of that. I have 216 over n cubed summation I squared from I equals 1 to n minus 216 over n squared summation of I from I equals 1 to n plus 72 over n into summation of 1 I equals 1 to n. From the previous classes, you would have seen summation I squared and summation I. I'm going to input that directly. We have the limit as n tends to infinity of what? 216 over n cubed into n plus 1 into 2n plus 1 all over 6 minus 216 over n squared into n plus 1 all over 2 plus 72 over n into n. And so we are going to try to cut out the cuttables. 6 here 1, 6 there 36, 2 here 1, 2 here 108, n here 1, I'm left with n squared there. N here 1, I'm left with only n here, and this removes that. We have the limit as n tends to infinity of 36 over n squared. By the time I open that bracket, I have 2n squared plus 3n plus 1 minus 108 over n into n plus 1 plus 72. Moving ahead from there, we have the limit as n tends to infinity. Let's try to open this up. We have 72 n squared over n squared plus 108 n over n squared plus 36 over n squared minus 108 n over n minus 108 over n plus 72. I am sure you can see that some things can cut. So we'll try to cut the cuttables there. We'll try to cut some of the cuttables there. And so we have what? The limit as n tends to infinity of 72 plus 108 over n plus 36 over n squared minus 108 minus 108 over n plus 72. By the time we take the limit as n tends to infinity, this goes to 0, that goes to 0, and this goes to 0. We are left with what? 72 plus 72 minus 108. That is 144 minus 108. And we have what? 36. Therefore, the integral from minus 2 to 4 of our f of x, which is what? X squared minus 2x plus 4 is what? 36. That will be the integral when we use the Riemann sum. I'm going to leave us with an example that we can try our hands on using the limit definition, and then I see you in the next video. Let's write the example that we can try our hands on. I'll use the black marker so we can identify it. You can try your hands on this. Given f of x equals 5x minus 2, find the area under the curve bounded by the interval 1, 4 using limit definition of the Riemann integral. Using the limit definition of the Riemann integral. What they want us to do is to find the integral of 5x minus 2 dx from 1 to 4 using Riemann sum or using the limit definition. Thank you very much and God bless you. See you in the next video.